टू क्वालिटी एजुकेशन क्लासेस। आज हम लोग पढ़ेंगे काइनेमेटिक इक्वेशन ऑफ यूनिफॉर्मली एक्सेलरेटेड मोशन बाय कैलकुलस मेथड। तो कैलकुलस मेथड देखिए, सबसे पहला है हम लोग को एक्सेलेरेशन। एक्सेलेरेशन इक्वल टू क्या होता है, डी बाई डी टी। ए इक्वल टू डी वी अपॉन डी टी। रेट ऑफ चेंज ऑफ वेलोसिटी इज कॉल्ड एक्सेलेरेशन। अगर मैं इसको इधर लेकर चला जाता हूं, a dt equal to dv, then if we put integration sign on both sides, then what happen? For constant acceleration, a come out from the integration part and it becomes dt equal to integration of d. Suppose that at time 0 velocity is our v naught, and time when become time t, then velocity becomes v. If I am putting this integration limit on upper side, upper and lower, then can we write here a time 0 to t velocity v naught to v d. Then what happened? A the integration of dx is what? x. तो इंटीग्रेशन ऑफ dx, तो यहाँ पर क्या हो जाएगा? t. Then we put limit 0 to t. Here what? Integration is v, and when we put v naught to v, then what happened? You can see here a into t minus 0, upper limit minus lower limit. Here v minus v naught. So can we write this v equal to v naught plus at? This is the final expression of kinematic equation of uniformly accelerated motion. This is the first equation. Again I am going to explain. Acceleration is a dv by dt, rate of change of velocity is called acceleration. Again, if multiplied cross multiplication a dt, then it becomes such kind of expression. Applying integration on both sides, acceleration is a constant, then it comes out from the integration side. Then again putting lower limit and upper limit at t equal to 0, velocity is v naught, initial velocity, at time t velocity is final velocity. I am putting here upper limit and lower limit, respective time length and velocity. After that integration, we put the upper limit and lower limit. Here you can see, first put the upper limit, then subtract it from the lower limit. First put the upper limit, then subtract it from the lower limit. After rearranging, we get the v equal to v naught plus at. Again I am going to second equation. तो सेकेंड इक्वेशन हमारा है velocity is defined by rate of change of displacement. तो यहां पर हम लोग देखते हैं सेकेंड इक्वेशन। v equal to dx upon dt, where dx is what? Rate of change of differential operator है किसका? Displacement का. तो rate of change of displacement with respect to time is called velocity. If we cross multiply here, v dt equal to dx, and from the first equation you have already calculated v equal to v naught plus at. I am putting the value of v equal to v naught plus at from first equation, जो पीछे जो इक्वेशन हमने डिराइव किया. Then what happens? Then v equal to v naught plus at dt equal to dx. V naught dt plus at dt equal to dx. Putting integration on both sides, The integration is distributed here. V naught dt plus integration of a t dt equal to integration of dx. I am putting here limit, lower limit and upper limit. When time is 0, then what happens? Our x become x naught. Initial position of an object. When time becomes t, then position becomes x. Put the limit 0 to t, 0 to t, here x naught to x. After integration, we get v naught is a constant value, and putting the lower limit and upper limit, then a t square upon 2 here 0 to t equal to x minus x naught. Again, you can see here, v naught t v naught t v naught t plus a t square upon 2, then x minus x naught, x become x naught plus v naught t plus half n t square. This is the generalized equation of second. If our position is x naught at origin, if x naught becomes 0, then equation becomes x equal to, if x naught अगर हमारा 0 हो जाता है, then equation becomes x naught equal to v naught t plus half a t square. This is the second equation of uniformly accelerated. Then I am going to third equation. Third equation is acceleration equal to dv upon dt. I have already know rate of change of velocity. If we divide dx and divide and multiply it by dx and d in this equation, we get dx by dt. Already we know v equal to dx by dt. If I am put here a equal to dv by dx and v cross multiplied here, a dx equal to v dv, integrating on both sides. If initial velocity is v naught, initial position is x naught, final velocity is v naught, final position is x, then a is the acceleration constant. A is out of integration, and we put lower limit and upper limit. V dx and v dv is here, integration is v square upon 2. V naught is our lower limit and upper limit. After putting the limit here, you can see a x minus x naught equal to v square minus v naught square upon 2. If we cross multiply here, 2a x minus x naught equal to v square minus v naught square. After that, again we are putting the final equation here. You can see v square equal to v naught square plus 2a x minus x naught. If our x naught is 0, then what happens? If x naught initial position around 0 बोल देते, then what happens? V square equal to v naught square plus 2ax. This is the third equation. V square equal to V naught square plus 2x. This is the third equation. Again, I am going to finalize here. First equation is what? V equal to V naught plus 80. Second equation is what? X is equal to V naught t plus half 80 square. And third equation is what? Third equation is what? What happened? Third equation is V square equal to V naught square plus 2ax. This is the final three equation of kinematic. This is the final three kinematic equation of uniformly accelerated motion. You should remember it, and I am deriving this formula by using calculus method. Thank you.